Hello and welcome to this video about switching basics, learning, forwarding, filtering, and interface settings. So what are your objectives with this video? Well, first of all, it'll help you predict the type of entries to be found in a switch's MAC address table. Second, you'll see how to describe the switching process and how it makes a forwarding or a filtering decision about each frame. And then the end of the video shows how to configure the interface speed and duplex settings, as well as the switch IP address and default gateway.
This lab uses two main scenario steps. In the first step, we'll review the learning, forwarding, and filtering process, and then from the CLI, see the process by which a switch adds entries to its MAC address table. Then in the second part of the scenario, we'll see how from the CLI you can configure things like the speed and duplex on an interface, the IP address of the switch, and its default gateway. So let's begin with step 1. In step 1, we'll use a simple switch network with two switches, switch 1 and switch 2, and they're connected via a trunk. Now as you see here, PC3 is connected to switch 1, and its MAC address is 0033.3333.3333, so we'll call that MAC address 3. Now when the PC is hooked up, switch 1 does not learn a MAC address. However, when PC3 sends its first frame, whose source address is MAC address 3, switch 1 learns that MAC address, adds that MAC address to its MAC address table, and lists the interface FA0/13, which is the interface on which switch 1 heard that frame. Similarly, when switch 1 forwards the frame over to switch 2 hears the frame, looks at the source MAC address, sees MAC address 3, and adds an entry to its MAC address table, this time with switch 2's FA0/24 interface listed in the MAC address table. Now if we hook up a second PC, in this case PC1 with MAC address 1, when PC1 sends its first frame, switch 1 looks at the source MAC address, adds that MAC address to its address table, and then as switch 1 forwards the frame down to switch 2 does the same process, looking at the source MAC address of the frame and adding that entry to switch 2's MAC address table. For completeness, we'll hook up a PC, in this case PC2, down there off switch 2. When PC2 sends its first frame, switch 2 notices the source MAC address of MAC address 2, adds that entry to its MAC address table, and of course switch 1 does a similar process by adding MAC address 2 to its MAC address table as well. Next, let's take a look at the forwarding and filtering decision made on the switches when PC3 sends a frame destined to PC1. As you see there, PC3 sends a frame of destination MAC address 0011.1111.1111. Now when switch 1 receives the frame, it looks at the destination MAC address and matches that against its MAC address table. Now you see the highlighted second entry in switch 1's MAC address table tells switch 1 to forward that frame out its interface FA0/11, so switch 1 forwards the frame out to PC1. So that's the forwarding decision. The filtering decision is switch 1's decision to not forward the frame out any other ports. For instance, in this case, switch 1 does not forward the frame down to switch 2. That'd be called the filtering decision. Next, consider a frame sent by PC3 to PC2's MAC address. As the frame comes into switch 1 again matches its MAC address table, but in this case, switch 1 matches the third entry that you see highlighted on the screen. Based on that entry, switch 1 forwards the frame out its FA0/23 interface down to switch 2. Of course, switch 1 chooses to filter or not forward the frame at its top interface FA011. Now once the frame gets down to switch 2 repeats the same process, looking at the destination MAC address of the mostly 2's MAC address, matching that third entry in switch 2's MAC address table, causing switch 2 to then forward the frame out its interface FA0/12. Next, we'll take a look at the command line interface and see the learning process occur. You might want to have your booklet open to Lab 3's chapter so that you can see a picture that shows all the MAC addresses. Here on switch 1, we use the show MAC address table dynamic command, as you see there. And notice there's only one entry in the MAC address table, and that's not for any of the three addresses in the picture. This is an overhead MAC address used for some messaging between the switches. Now, not shown on the screen, if I go over to PC3 and cause them to send a frame, then I come back here to switch 1 and do another show MAC address table dynamic command. Notice MAC address 0033.3333.3333 shows up in switch 1's MAC address table off interface FA0/13. Now if we switch over to switch 2 for a moment and do a show MAC address table dynamic command, by the way, this command shows all the dynamically learned entries. Notice that switch 2 also learned PC3's MAC address, and notice it lists FA0/24 as the interface, because switch 2 received the frame sent by PC3, received that frame on switch 2's FA0/24 interface. Now both switches know about PC3's MAC address. Next, not shown on the screen though, we'll have PC1 send a frame. Now in switch 1, if we repeat the show MAC address table dynamic command, as you see here, PC1's MAC address of 0011.1111.1111 shows up there in switch 1's MAC address table off port FA0/11, and the same command over here on switch 2 shows an entry for that same MAC address, but notice it also lists support of FA0/24. Finally, not shown on the screen, we'll have PC2 send a frame, and sticking with switch 2 for now, notice the show MAC address table dynamic command on switch 2 now lists PC2's MAC address, as you see there, off of port FA0/12, and up on switch 1 we'd also see an entry for PC2's MAC address as well. Next, at step 2, we'll go over some of the basic switch configuration options. First, we'll look at how to configure a couple of key parameters on interfaces, namely the speed and duplex. For most end-user connected ports on a switch, you'll let these values be auto-negotiated, but it's useful for the exam to understand how to configure them. For instance, here we see the interface command followed by the speed and duplex commands. Speed and duplex commands set the speed and duplex, obviously, and these are interface subcommands. So we'll see how to do that. Additionally, we'll set the IP address on the switch. Now the IP address is typically configured under an interface called interface VLAN 1. VLAN 1 is typically used for management purposes. So to configure a switch's IP address, we use the IP address command under interface VLAN 1. Additionally, a switch thinks like a end-user host in regards to IP, so the switch needs to know its default gateway, and we'll use the IP default-gateway command that you see there. The table of commands is in your booklet, so you might want to refer to that while we're going through the CLI. But first, let's talk about the IP addressing scheme used here. Notice PC 1, 2, and 3 have IP addresses that appear to be in the same subnet. Now, if we've got a router attached to that same subnet, it'll of course need an IP address in that same subnet as well. In this case, R1's address is 172.30.1.251. So switch 1 and switch 2 both need an IP address, and their IP addresses need to be in that same subnet, which in this case is subnet 172.30.1.0 with a /24 mask. So in this case, we've chosen to give switch 1 an IP address of 172.30.1.101, and we give switch 2 a similar IP address ending in .102. Also, their default gateway configuration will point to R1's IP address that you see there. So let's start by looking at switch 1's FA0/23 interface, where we'll set the speed and duplex. This is the interface connected up via a trunk over to switch 2. So to configure it, we'll get into configuration mode, of course, and then get into interface configuration mode for interface fast Ethernet 0/23. At that point, you can use the duplex full command that you see here. Now I'm going to press the enter key. Then I'll use the speed 100 command to set the speed. Notice that an unsolicited console message just showed up. That's a log message, and it notes that the switch took down interface fast Ethernet 0/23. Anytime you set the speed or duplex on an interface, the switch is going to bring the interface down and then bring it right back up. As you see there, we've got a message that says that the line protocol is back up on interface FA0/23. So now the interface is up and operational again. Next, let's look at how to configure IP on a switch. Switches act like a host in regards to IP, so we need to give the switch an IP address. To do so, we get into interface VLAN 1 configuration mode with the interface VLAN 1 command that you see there, and then we use the IP address command to assign an IP address to the switch. Notice here we're using address 172.30.1.101 with a mask of 3 255s and a 0. Now once I press the enter key, the switch has an IP address, but it turns out interface VLAN 1 is shut down by default. So to get this interface up and working, you have to use the no shutdown command that you see there, and that brings up the interface. Notice you get a message there that says that now the interface is up and working. Additionally, you have to configure a default gateway parameter on the switch. To configure that default gateway parameter, use the IP space default gateway command that you see there, and then you plug in the IP address of a router. In our case, we're going to refer to R1's IP address, namely 172.30.1.251. This concludes IC&D1 Lab number 3. This video has shown how to predict the types of entries that will be found in a switch's MAC address table. It describes how switches make forwarding and filtering decisions, and it shows several things from the command line interface, in particular how to set the interface speed and duplex settings, as well as how to configure a switch's IP address and default gateway.